Hello everyone, how are you all? I hope all of you are doing good. So here we are with the revision session of semiconductor, and probably this would be the last session that we are taking for the revision one. So we will move along in the same manner as we are moving further. We will see first of all the concept, and then we will try to solve the PYQs and understand the concept. Now these are the topics that include in this chapter named semiconductor. First of all, what is semiconductor? Semiconductor diode. IV characteristic in forward and reverse bias. Diode as a rectifier. And then IV characteristic of LED, photodiode, solar cell, and Zener diode. Zener diode as a voltage regulator, and these are the logic gates. So if I consider the 50-50 portion of it, 50% of the question is being asked from these two topics, and rest 50% of the question is being asked from these above four or five topics. Now let's just move ahead and start with the introduction. What is semiconductor? So semiconductor is a device, sorry, is a material. I would like to write semiconductor is a material type of material whose conductivity lies in between metals and metals say come, and it is greater than from the insulator. Okay. So suppose if metals having a conductivity, for example, like 100, and insulator having a conductivity like 5, the semiconductor lies in between. They must possess a conductivity of 45. This is just a data for example. It's not the accurate value. Now, according to band gap theory, there are two valence in a atomic structure. The first is the conduction band, which we can say at conduction band, and the second one is the valence band. Now, what is happening and what does happen for the metals? This for any material, most of the electron lies in the valence band, and when they get the sufficient energy, they will jump into the conduction band. This gap between conduction and the valence band is termed as the energy band gap. Energy band gap. Now, more is the energy band gap, more is the energy we require to make the electron jump into the conduction cell. And conductivity of a material is depend on how much electrons are there in the conduction band. So for metal, if I talk about for metals, these two bands overlap with each other like this. So this is the conduction band, and here only the valence band. So we require no energy to translate or to transfer the electron from valence band to the conduction, and that is why the conductivity of metals are too high. If we talk about the insulator, this is the conduction band and this is the valence band. So for insulator, this energy band gap is greater, is very greater than comparison to the metal. So here we can write higher energy band gap. So due to higher energy band gap, it requires a lot of effort to make the electron jump into the conduction band, and that is not possible. So that is why the conduction in insulator is negligible. So this is for the insulator. Now, again, conduction and the valence band. Now, if the conduction and valence band gap are close to each other, but not too close, there is a energy band gap, but that can be accessible, which electron can easily jump off. This energy band gap is lies between the energy band gap of metal and energy band gap of insulator, which means it is feasible for us to make the electron jump into the conduction band. So this type of material is termed as the semiconductor. So energy band gap is greater in insulator than semiconductor and then metal. So metal have minimum energy band gap or negligible energy band. So this is the story that how we identify or how we relate metal, semiconductor and insulator. Or in spite of metal, we should write as conductors. Conductors. So in conductor, we will having most of the metals are the conductors. So that's why we can write it as metal also. But here we are writing in terms of conduction, so it must be conductor. Okay. So for conductor, few points we have learned here. Conductor के लिए energy band gap is negligible. Conduction band is overlapping the valence band. But for insulator, this energy band gap is very high, so that electron cannot jump from the valence band to the conduction band. But if we talk about the same for semiconductor, this there is a existence of band gap, but it is not too high and not too low. So by putting some inputs like in terms of energy, heat energy, or whatever the energy we provide it, electron will absorb that energy and jump into the conduction band easily. And we can make the semiconductor behave as a conductor. Got it? Now, next point. Now, how many types of semiconductor do we have? So there are types of semiconductor. First is intrinsic semiconductor. Intrinsic semiconductor. And the second one is the extrinsic semiconductor. Extrinsic semiconductor. Now, what is intrinsic semiconductor? It is the purest form of a semiconductor material. Purest form of semiconductor material. For example, germanium and silicon. These are the two mostly known semiconductor material which are termed as the intrinsic semiconductors. So intrinsic semiconductor are the raw material that we extract from the earth's surface. So it is the purest form of the semiconductor material. Although it has some lagging also, it is not so much of conducting, not so much conducting. And that is why it is of no use for that. Like if it is not behaving as a conducting material, or we have to put a lot of input to make it conductive. So what is the use of it then? So then come the extrinsic semiconductor. What we will do, we will take a intrinsic semiconductor, we inject some impurity in it, we inject some impurity atoms or impurity in it. This is the intrinsic. And then it changes from low conducting material to high conducting material, and that is nothing but the extrinsic semiconductor. Semiconductor. Now, the process of injecting impurity, this injecting impurities is termed as doping. Process of injecting impurity. So there are two types of doping we can do. Either we can inject P type of material, P type, and this is N type. This P type of injection is also termed as pentavalent impurities. Sorry. P type of injection is termed as tetravalent, trivalent. Trivalent impurity we put, and this N type impurity may we put a pentavalent impurity. So if a question came, what is the conduction or what is the charge carrier, major charge carrier in P type semiconductor or N type semiconductor? So in N type semiconductor, charge carriers are electrons, the major charge carriers, and in P type of semiconductor, major charge carriers are holes. Okay, holes. Holes we also denote as a positive charge. Got it? Now for intrinsic semiconductor, you can learn this. Ne is equals to Nh is equals to Ni, where this is nothing but the number density of electron present in the intrinsic semiconductor, number density of holes present in the semiconductor, and number density of intrinsic. So these all are equal. Whatever is the number of electrons, same number of holes are there in intrinsic semiconductor. This is for the intrinsic semiconductor. But if we talk about the extrinsic semiconductor, this Ne multiplied by Nh is equals to Ni whole square. So this is nothing but the extrinsic semiconductor. I hope you got it. Now, let's just talk about the logic gates. Logic gates. So logic gates are nothing but a signal rectifier or signal amplifier, we can say. Signal filter, we can also say that. So based on this, we have three types of fundamental gates, which is nothing but the OR gate, AND gate, and NOT gate. Now, in electronics, basically we derive the signal as 0 and 1 form. Binary form में signal will travel always. And there is a different algebra for that, which is termed as the Boolean algebra. Okay. So if I talk about the OR gate, the structure of OR gate is look like a arrow, like this. It look like an arrow. So at the end of it, we provide two signal, but it will only filter out the one signal. So suppose how the OR gate works. If I provide it zero signal and here also zero, so the truth table for this will be, this is the input Y and this is input A, this is input B. So this is A, B and Y. So when signal is zero, which means low signal, there are only two types of signal, either zero or one, low or high. So when signal A is zero and B is zero, the resultant, which is Y, and if it is an OR gate, it will gives you zero. But if A is 1 and B is 0, then if only one value of it is true, it will provide you the true. 1 we can also say as a true value, true, and 0 we would say as a false. Okay. So 0 0 0 always, 1 0 1. Similarly 0 1 भी आपको 1 ही रिटर्न करेगा. It just require one true value. Now 1 1 will also 1. So this is the truth table for OR gate. Now AND gate, if I talk about, so AND gate is look like a LED bulb like this. This is the AND gate. Okay. Now again we will draw the truth table for AND gate. The concept of AND gate is very simple. When both the signal will be true, then only it will return, otherwise false. So A, B and Y. So if A is 0, B is 0, both the signal are false, it will return you as a false. If A is 0, B is 1, it will return 0. If A is 0, B is 1, it will also return 0 then. Why? Because it will only return 1 when both the signals are 1. If either of the signal is 0, it will return 0. So 1 and 1, it will give you 1. Now this is for the AND gate. Now in terms of Boolean algebra, you can also write it. Y is equals to A plus B. Got it? But यहाँ पे ऐसा मत बोल देना कि A is 1 तो B is 1 तो Y is 2. No, in Boolean algebra, 1 plus 1 is 1. Got it? This is the formula for that. For this, it will be written as A into B. So if A is 1, B is 1, then only it will return 1. If A is 0, B is 1, Y will 0. If A is 1, B is 0, then also it is 0. Now the third gate is NOT gate. NOT gate. Now NOT gain B, it's a triangular gate having a circle at the front like this. It's a single input gate. If you return 1, if you give 1, it will return you as 0. If you provide the input at 0, it will return you as 1. It just reverse the value, nothing else. So why we can say A bar. A bar means whatever the A is, it just reverse the value of. If A is true, then Y will be false. If A is false, then Y will be true. Now, based on these three gates, we have a fundamental derived gate, we can say, not fundamental, which are the first is NOR gate. NOR gate is nothing but the combination of OR plus NOT. So if you see the truth table of OR gate or the expression for OR gate, which is nothing but Y is equals to A plus B. So for NOR gate, it will become A plus B ka bar, which means if A is 0, B is 0, then it will coming out as 0. But bar means if downside is 0, it will return you as 1. So the truth table will become, this is A, this is B, 1 0 0 1 0 0 and 1 1. The return of this for NOR gate I'm talking about, 1 0 for OR gate, it should be coming as 1, but it is not is also applied, so it will return you 0. 0 1 also 0. 0 0, it would return as 0, but due to the NOT gate, it will convert it into 1. The similar goes with 1. 1 plus 1 return to be 1, but it is 0. Got it? So this is the structure of NOR gate. Now the another gate is nothing but the NAND gate. NAND. NAND is the combination of, you can easily guess it. It is the combination of AND plus NOT. Okay. Now, So the truth table for and is 0 0 0. So it would be written as y is equals to a dot b. This is for the and gate. So to not convert it into NAND, we just put a bar on it. If you go through the table, a truth table of it, a b y. If a is 0, b is 0, according to AND gate, it should be 0, but here the NOT is also in action. So it will provide you 1. If a is 1, this is 0, AND gate will provide you 1, sorry 0, but it will give you 1. For 0, 1 also, this is the similar case, and for 1 and 1 should be 0. Now, based on that, we have a questions here. So this is the question from this is the question from JEE Main 2024, and it's based on the logical gate. Now it's very clear the table is mentioned here A, B, E. E is the output, final output here. Got it? Now I just forgot to mention the symbol for NOR gate. So OR gate will be written as a arrowhead. So for NOT gate, just put a circle in the front. For NAND gate, it should be LED, just a little dot in the front. So here we can easily identify the gate. This is the OR gate, AND gate. This is also AND, and this is slightly more curvy. So this is, and in front of it, it is a dot provided. So it will behave as a OR gate, NOR gate. Okay. So you can check it with the signals. Only 0 and 1 you have to check, and 1 and 0. Everything is given to you. Now for 0 and 1, you can also take up the idea. If for 0 0 it is also 0. For 1 1 is also 0. So for 0 1 and 1 0 it should be 1 and 1. This is the pretty much understood now. But let's just take the values and understand. We given a signal of 1 and 0 and 1, let's say 0 and 1. So at A it will be 0, and at B it will be 0. So for this AND gate, it will give you as 0, because AND gate gives you 1 when both the values are 1 or both the values are 2. But it is only one values is 1, or we can say the true value. So it will provide you a 0. Similarly, when this 1 output goes here, this is the NOT gate in action here. So 1 we have provided at the B end, this one, and 0 we have provided at this side. So when the 0 will travel, NOT gate will convert it into 1. And when the 1 will travel to the NOT gate, it will convert it as 0. So again, 0 and 1 is the input of this AND gate. And again, it will be provided you as 0. So the both the input here are 0 and 0. So we know that NOR gate will provide 0 0 ka 1. You can see here. NOR gate will provide for 0 0, it will provide 1. Or we can also say that OR gate will provide what for 0 0? 0. And there is a NOT gate in action. So it will convert the 0 signal to 1. Now for 0 1, if A will be 1, B is 0, the same repetition will be there. बस यहाँ पे थोड़ा change होगा. This 1 value will become 0, and this 0 value will become 1. Again 0 1. We can say option 1 is the correct answer. Now if I move further, a light emitting diode LED is fabricated using GaAs, gallium arsenide, semiconducting material, whose band gap is 1.42 electron volt. The wavelength of light emitted from the LED is. So for that we know this is the energy band gap, which means this is the energy 1.42 eV electron volt. 1 electron volt, always remember it is nothing but 1.6 10 raised to the power minus 19 joule. Okay. Now, for wavelength emitted by the LED, and this is the wavelength in the form of light. So we know according to Planck's formula, E is equals to hc upon lambda. Now lambda will become hc upon E. We know that h has a value of 6.626 10 raised to the power minus 34. C is 3 into 10 raised to the power 8 meter per second. And E has been provided as 1.42. So we can convert it into joule. 1.42 into 10 raised to the power minus 19 multiplied by 1.6. Okay. So by this formula, you can get the value of lambda. The wavelength that is emitted by the light, emitted by the LED, light emitting diode. So that must be come out as 875 nano. Now again, this is the question. The output Y of the following circuit for given inputs is. Now, the output Y of the following circuit for a given input is. Now, it seems very complicated circuit, but it's very easy to understand. Here is AB and here the Y resulting. Now, we have to relate this Y with A and B, how they are behaving. Now, we know that if we provide 1 and 1, both at A and B, so one will travel at this end and one will also travel at this end. And this is nothing but the OR gate and this is nothing but the AND gate. This is not, this is not. So when this one signal travel to this, it gives you here, it will be retain its value as 1. But when the signal travel 1 from the B, there is a NOT gate in between and it will be converted as 0. So 1 0 1 0 and this is the OR gate, so it will filter out as 1. Because any value will be true, it will give you a true input, true output. So 1 is here. Now let's talk about B. So this is also AND gate. Two inputs are required. So one is directly coming from the B, which is 1, and one is coming from the A, which is also 1. But for here, from here up to here, there is a NOT gate in between. It will convert it into 0. So 1 0 and this is the AND gate, so it will give you 0. Got it? Finally, the signal that we are getting is 1 and 0. And 1 and 0 will give you, and this is again the AND gate in front of, so it will give you 0. So we can say for A and B, we can make the truth table here, Y. So if A is 1, B is also 1, Y give you 0. Got it? Now, just change the value to 0, 0. Then again, we will see what is happening. When we take it at 0, 0, this 0 will travel here, but 0 will convert it into 1 because of this NOT gate. And again, the signal that this OR gate provide to us is 1. 0, 1 will be 1. But for this AND gate, we will see this 0 from A will convert it into 1. B already having 0, it will give you 0 output. And again, here is 0, here is 1. So 1 0 will again give you 0 because this is the AND gate. To get the value 1, both the values need to be true. So for 1 and 0, it will be 0 again. Now what's about 0 and 1? What about 0 and 1? Let's just see. So 1 will come here as 1. 0 will also come here as 1 because of the NOT gate. So 1 and 1 will pass out as 1 from the OR gate. 1 is coming out as 0 here, and 0 is also coming out as 0. So 0, 0 will become 0 for the AND gate. So 1 and 0 again, AND gate will filter out 0. Okay, that is for 0, 0. 1 and 0 is 0. Okay, okay. 1 and 0 is coming out as 0. Now let's just do it for 0 and 0. I think we have did it. I just forgot it. Let's just do it quickly. So 0 will come here as 0. 0 will come here as 1 because of the NOT gate. Here the 0 will come as 1, and this 0 will come as 0. So 1 0 from OR will be 1. 1 0 from AND will be 0. So 1 and 0 will be 0. So for 0 0 it's 0. It's true. Now only one input that we are lagging with is 0 and 1. So if A is 0 and B is 1, so 0 will come here as 0, but 1 will also come here as 0. So it will provide you 0. 0 from A will become 1 here. 1 is also 1, so it will provide you 1. Got it? Now 0 and 1 again coming here, so it will give you 0. So for all the output, for all the inputs of A and B, it is giving you a 0 value. So which expression of it is satisfying this? Now clearly A dot B is not satisfying it. A bar dot B is not also satisfying because when A is 0, A bar will become 1. Got it? And B is 0. If we take B is 0, so it will be 0, 1 always. If A is 1, it will give A bar give you 0, and B will, let's say B is 0, so 0. Now what? For this value, it can be changes. And if you take B as 1 and A as 0, so A bar gives you 1. So A bar dot B, 1 and 1 gives you 1, but here we are not getting any 1. So this also is not correct. Got it? Now, the correct output we are getting is 3. Okay. So option 3 is the correct answer for it. Got it? I hope that you have got this. Now this is it for today, and best of luck for your exam, for both, for the boards exam, pre-boards you are having, and for the JEE Mains, and wish you a very good luck. Thank you so much, guys, for being attentive and being responsive. Bye bye. Take care of yourself.